Let's work on a few more problems. This is Comprehensive Trig Review Part 4, and this is question number 39. This one comes with a crazy looking graph. Here are some of the pieces. The angle POQ, P to O to Q is the angle theta. So there's the angle theta. PQR is 90 degrees, so this side's going to be 90 degrees. They also say theta is 13, so here's 13, which makes this one 77 because these are axes. Let's see, VRQ, so V to R to Q is 90 degrees, so right there. So this is a vertical line, okay? And we've got to find the length from here to here, U to S, to 4 decimal places. So that's the plan. All right, so let's look at some things. I have determined, and let's see why, but if this is vertical and this is vertical, and this line intersects them both, then from the vertical down to the line is 77. So there's a 77. Now, this came straight across, so these are right angles. So this one's 13. 77 and 13 gives you 90. So that's a 13-degree angle. Okay, so now if I look at this big triangle right here, then I've got the opposite is 1 because it goes from 0 to this point, 0, 1. So that's 1 unit long. And the value US is the length of the adjacent. So the tangent of 13 is 1 over the magnitude or the length of the line US. So what I'm going to do is I'm going to multiply both sides by US, the length of US, and divide both sides by tangent 13. So I get length of US is 1 over tangent 13, and throw that in my calculator in degrees, and look what I get. I get 4.3315. That's in 4 decimal places. So kind of interesting outcome. Okay, next question. A pulley is centered and is going through rotations. It goes through 22 rotations. What's the angle in radians? Well, each rotation is worth 2 pi, so 2 pi times 22 is 44 pi. Okay. Next question. What's the exact value of the cosine of minus 2 pi over 3? Well, the minus 2 pi over 3 is in quadrant 3. And so cosine is negative there. The value of the cosine of 2 pi over 3, the reference angle is pi over 3, so the value is 1/2. So you get a minus because of quadrant 3 and a 1/2 because of the reference angle. Next question. The cotangent of S is 0.6921. Find S between 0 and pi over 2. So I've got to get my calculator out, put it in radians, because this is in radians. I don't have arc cotangent on the calculator, so I'm not going to use that, but I do have tangent, arc tangent. So flipping this flips this reciprocal. So the tangent is 1 over 0.6921. So if I take arc tangent of this, make sure I'm in radians, and I get 0.9654 if I round to 4 decimal places. So it's approximately 0.9654. Now, next question that I actually already have done, I'll do some for you here in a minute, but next question says omega, or the angular speed, is pi over 8 radians per minute. T is 11 minutes, and a relationship is omega is theta over t. Find the missing piece. Well, that would be theta. So I put it in here. Pi over 8 is omega. Theta over time is 11 minutes. I multiply both sides by 11 minutes. Cancels the minutes all the way through. Cancels the 11 here. So I get theta by itself. 11 pi over 8. That's in radians. So there's where we are with that one. Now, some fresh problems. 44. And I'm just numbering these. This one has some kind of a figure that we need to get, and we need to find out some information. So we've got a figure that intersects a point, and the point is minus 5/13, 12/13. So there's a point, and we're supposed to find the cotangent of the angle that's described here. Well, if this is a point, it's in quadrant 2 because it's left of the origin and up above the x-axis. But cotangent is, by definition, x over y. So it is the x value, which is minus 5/13, over the y value, which is 12/13. Multiply here by 13 over 13. That cancels. That cancels. We get minus 5 over 12. So there's the cotangent of that angle, exact value. Don't even need a calculator. All right, let's go a little further. Here I've got a pulley again. So those are kind of common questions. So a pulley of radius 25 centimeters, 45 here. So the pulley has radius equal to 25 centimeters, and it rotates 7 rotations in 4 seconds. So find the angular speed. Find the angular speed. Omega is what's called the angular speed. Okay. Now, angular speed. Guess what? If it's got a radius of 25 centimeters, that does not matter because it doesn't have anything to do with the angle. Okay, everything has to do with this. So what's the angle of 7 rotations? Well, 7 rotations is equal to 2 pi times 7 in radians, or 14 pi per, so it goes 14 pi per 4 seconds. Okay, we'll reduce that a little bit. You get 7 pi over 2. This is in radians per second. So kind of reasonable. Sorry about that. I didn't mean to cover it up for you. Let's check another question. Now, if you happen to have the paper copy of this one, it's got 46, which talks about linear regression. And that's actually more an algebra thing. I know you do that some in trig, but we're not going to worry about that one. So if you happen to see the paper copy of this thing that I've got with this, don't worry about it, okay? Now, let's talk about 47. 47 has a weight attached to a spring, and we've got this. We've got S of t is equal to minus 2 times the cosine of 6 pi t, and that's inches, and t is in seconds. Okay, what's the maximum height that the weight rises above the equilibrium position? This is a graphing question, believe it or not, because this is a cosine function. So where's the cosine maximum? Well, normally you have a cosine function that looks like this when you graph it, okay? And the maximum is where you start, okay? How high up is that? Well, that's normally 1. However, this has a magnitude of 2. And it's flipped over, okay? It's reciprocal reflection. So what is the maximum, the highest? The highest would be 2. So max would be 2. Okay? It didn't say when that happened, so you could figure that out if you wanted to, but you don't really have to in this question. All right, here is a graphing question. Y equals minus 2 times the sine of 1/4 x minus pi over 4. What's the phase shift? Okay, phase shift that comes from here. Set this equal to 0. Add pi over 4 to both sides. You've got 1/4 x equals pi over 4. Multiply both sides by 4. You get x equals pi. Okay? That's a phase shift. So, phase shift. Next one. Here is same question, different, or same instructions, different question. Y equals minus 2 times the sine. It's almost the same question too, but here's 2x minus pi over 2. Phase shift, 2x minus pi over 2 equals 0. Solve for x. So add pi over 2 to both sides. You get 2x equals pi over 2. Multiply both sides by 1/2, or divide by 2, I guess, would be equivalent to that. So x equals pi over 4. So there's your phase shift on that one. Okay. So if you happen to have some version of this, you got a matching question, 50, to match some graphs. I'm not going to worry about that with this video. So if you happen to be watching that part, let's describe some things here. Let's talk about what happens when you've got y equals 1/4 tan 2x. Okay, looks like what function? Well, it looks like tangent x, doesn't it? Okay, but it has amplitude what? 1/4. Phase shift. Where's the angle? 0. X equals 0. Phase shift is 0. Okay. Period. Originally tangent is pi. So pi divided by the leading coefficient of x. So period is pi over 2. Okay. Vertical shift is any number that's added or subtracted afterwards. That's 0. Okay. Reflections. There aren't any negatives anywhere, so nope, no reflections. So there's some info about the graph of that one. Now, here are some other kind of quick questions. 52, y equals minus 2 times the cosine of 3x plus pi over 4. What's the amplitude? Amplitude is equal to 2. Not minus 2, just 2. It talks about how far up and down it goes. So amplitude is 2. Okay, let's talk about, analyze the graph information for this one. Sine of x plus pi over 3. So amplitude, well, first of all, it looks like a sine function. Okay, amplitude, there's no number here, so the amplitude would be 1. Phase shift, set that equal to 0 and solve for x. You get minus pi over 3. Vertical shift, there is no value added or subtracted afterwards, so that would be 0. Okay. Period. Initially, sine is 2 pi. Take 2 pi divided by the coefficient of x. Coefficient of x is 1, so it's 2 pi. And then, are there any reflections? No negatives anywhere, so nope, no reflections. So there's some analysis of that graph. Okay. One more analysis of some graphs. Got the y equals the cosine of 3/4 x. So looks like a cosine function. Amplitude, number out here, there isn't one, so it's 1. The period, Cosine is normally 2 pi. So you take 2 pi divided by the coefficient here. So 2 pi over 3/4, which is 2 pi over 1 times 4 over 3. So it's 8 pi over 3. So that's kind of an interesting period. Okay. Phase shift. Set this equal to 0, you get x is 0. Vertical shift. There is nothing added or subtracted afterwards or before. There aren't any negatives, so no reflections. And so you're done. Okay, so that's enough for this one.